Somewhere, not far from Earth, a star dies and explodes in a violent supernova, leaving in its wake the strangest phenomenon in the universe, a black hole. Our galaxy is infested with millions of them, but recently, black holes have been discovered that are bigger, stronger, and more destructive than ever imagined. Black holes are thought to be far away, but what if there was one closer than we think?
We know mass distorts space. We know light is affected by gravity. And we know Einstein's theory of general relativity makes possible one of the strangest objects ever imagined by physicists. If you could create a large enough distortion in space-time, by placing enough mass in a small enough space, you could create a region of space-time so strongly curved that nothing, not even light, could escape it. And since nothing can travel faster than the speed of light, anything that entered this region of space-time would be trapped there until quantum mechanical effects allowed it to escape.
I think of a black hole as the symbol of what it is we don't understand about the universe.
What are black holes made of?
Oh, okay. Already you've asked me a question that I can't answer.
So are black holes made of anything?
Okay.
Black hole. We don't really have any idea what's going on, so.
I don't understand black holes. I love black holes. I love black holes because I don't understand them.
There are many strange things in this universe, but I think I've picked the weirdest thing to actually study, which is a black hole. Stars, like our sun, are essentially big hot balls of gas that have nuclear generators in their core that create all the heat and light that we see shining. Stars are enormous. You could fit 1 million Earths inside the sun. And the sun is not even an abnormally large star. But the most fascinating thing to me about stars is that they die.
Stellar mass black holes are formed when stars, 20 times or more times the size of our sun, finally run out of fuel in their cores, and they rapidly cool and collapse, and the shockwave from the collapse blows the outer layer of the stars to bits in a colossal explosion called a supernova. But the small, dense core of the star can remain bound together by the force of gravity. As it continues to collapse under its own weight, the atomic particles of the core are smashed together until all that is left is a black hole. In its center lies the singularity, the mass of the entire star crushed into a single point in space. Surrounding that is an invisible shell called the event horizon. This is the cosmic point of no return. Once inside the event horizon, nothing, not even light, can escape, except through quantum mechanical processes. Supermassive black holes may contain billions of times the mass of our sun. These monsters lay at the center of every large galaxy. Micro black holes have tiny masses in which the effects of quantum mechanics are very important. Black holes of this type have been proposed to have formed during the Big Bang and would quickly evaporate due to said quantum mechanical effects. At the end of their life, it is believed that they would emit a sudden burst of energetic particles, but no such particles have been detected as of 2008. We can never know about what happens inside the event horizon of a black hole. In fact, any object that crosses the imaginary line has left this universe for good. If nothing, not even light, can escape a black hole, then who do astronomers and what do astronomers use to detect the black holes? The only way to spot a solid black hole is to study the bent starlight behind it.
Near a black hole, gravity would be so strong that an observer, standing, watching you jump into the hole, would see something quite strange. They wouldn't see you get sucked quickly into the hole. Instead, they would see your approach become slower and slower and slower, until you reached a point known as the event horizon. This is a point in space where, once crossed, there's no going back. It is at that point that light can no longer escape. And so to a person watching you fall into the hole, that would be where your journey ended. You would seem almost frozen in space, the light coming off your body becoming increasingly red-shifted until you simply faded into nothingness. They would never see you cross the event horizon.
In conclusion, we can all agree that black holes are the cold remnants of former stars that are so dense that no matter, not even light, is able to escape their powerful gravitational pull. Black holes are the most unknown subject in astronomy as of today. Scientists have been working harder and harder to understand what goes into black holes and how they work, but as of now, nobody really knows what happens past the event horizon.